Hey, how you doing? So you just saw some videos about Venn diagrams and parts that are in Venn diagrams, what it means to be inside a set, outside a set. Now what we're going to do is we're going to look at how that applies to probability. So I've got this handout here. You can download it from my website. And we're going to look at example 1. Choose a day at random. Because we live on the Gulf Coast, suppose there's a 21% chance it's raining. There's an 18% chance that I brought an umbrella because I don't normally worry about the rain. And furthermore, there's a 15% chance that a randomly chosen day is raining and I brought my umbrella. So the first thing I want to do is I want to try and describe that with a Venn diagram. So first, rectangle represents everything. And we have two possibilities. We have that it could be raining. And I'm going to abbreviate that as R. So I'm making a note right here. R represents raining. So this circle right here represents the chance that it's raining. And then we also have whether or not I brought my umbrella. And I'll use U to represent umbrella. So here's a second circle for umbrella. Now what I want to do is I want to take the numbers that are in this problem and I want to put them into the picture. Well, I've been told that the probability that it is raining is 0.21. But now I got to be careful. That raining means this entire circle. So with that in mind, when I look at writing this in, that doesn't mean this part's 0.21, and that doesn't mean this part's 0.21. That means both parts together are 0.21. And I've got a guest joining me who's going to be coming onto camera in just a few minutes, but I'll keep talking. So before I can go putting in that number, I need to remember that the probability that it is raining and I brought my umbrella is 0.15. Now that's this overlap right here. So I got 0.15 in this overlap, but this entire circle is 0.21. So to figure out what goes there, I've got to subtract 0.21, the size of the entire circle, minus 0.15, the chance that it is both raining and I brought my umbrella, and that gives me 0.06. Similarly, I know that the probability that I brought my umbrella on any particular day is 0.18. But that's this entire circle. So if 0.15 of my 0.18 is here, then 0.18 minus 0.15 means this is 0.03. And then the rest would be what's left out here. So let's see, 0.06 plus 0.15 is 0.21, plus 0.03 is 0.24. So 1 minus 0.24 is 0.76. That's the chance that it's not raining and I did not bring my umbrella. Okay, so let's go down to the remaining questions now. Question B asked, what is the probability that it is not raining? So that's probability raining complement. Well, anytime you want to find out the chance of something not happening, you just do 1 minus the chance that it does happen. So the chance of not raining is 1 minus the probability that it does rain, which is 1 minus 0.21, which is 0.79. So there's a 0.79 chance that it is not raining. So I look at C. What is the probability that I did not bring my umbrella? Well, again, that's 1 minus the probability that I did bring my umbrella. So that's 1 minus 0.18, which is 0.82. So there's a 0.82 chance that I did not bring my umbrella. That's going to get pretty crowded up here pretty fast, so I'm going to erase a little bit. Going on to question D. What is the probability that it is raining, but I did not bring my umbrella? Raining and not my umbrella. Well, where is it that it's raining and not my umbrella? Well, raining is inside this circle and not my umbrella is outside this circle. So I need to find what's in this circle but outside that circle, That's 0.06. So 0.06 is the chance that a randomly chosen day is raining and I did not bring my umbrella. Okay, what about E? What is the probability that it is not raining and I brought my umbrella anyway? Well, I can tell you that's not very likely. Let's see here. Not raining would be anything outside this circle, and brought my umbrella is anything inside this circle. So I need outside this circle, but also inside this circle. That gives me this little chunk right there, 0.03. And so that's D and E. Now we come to F and G. If you read F carefully, it says, suppose it's raining, what's the chance that Mr. Nunn brought his umbrella? Now that's called a conditional probability. So now this is not pick any random day. This is only look at the days that it is raining. So the days that it's raining means we're only looking inside this circle. And then it says, what's the chance that I brought my umbrella? Well, if I'm only looking inside this circle at the raining days, then the days where I brought my umbrella is this chunk right here, that 0.15. So let's put it all together. Probability that I brought my umbrella, provided that you know it's raining. That's the symbol for provided that you already know. So we already know it's raining. What's the chance that I brought my umbrella? That is the probability that both happened. It's raining and I brought my umbrella, divided by, that's this overlap right here, raining and brought my umbrella, divided by the chance that it's raining. So that's raining and brought my umbrella is 0.15. Out of this circle, the rainy days is 0.18. And now I'm going to need to go to my calculator. And my off-camera assistant has just reminded me that the rainy days are 0.21. Thank you very much, assistant. So I have 0.15 divided by 0.21 is 0.7143. Actually 0.71428, but I rounded. So 0.7143. So if it's a day that it's raining, if we already know that it's raining, there's a 71.43% chance that I'm going to bring my umbrella. And finally, G. Now G turns it around. G says, what if you see me with my umbrella? What's the chance that it's going to rain? So now the thing that we know, the precondition has been reversed. Now you already know that I brought my umbrella. What's the chance that it's going to rain? Well, if you already know I brought my umbrella, that means we're inside this circle, the brought my umbrella circle. So that's my denominator. And then I need the chance of raining, but only the chance of raining inside the brought my umbrella circle. So out of here, I need just this piece. That's the raining and brought my umbrella. So now the raining and brought my umbrella is 0.15. The chance that I brought my umbrella is 0.18. And I go to my calculator. I know that's 5 out of 6. And I get 0.8333. So this is how I can take a story, turn it into a Venn diagram, then use that Venn diagram to find some answers. Now, I'm going to bring my assistant on while I erase the board, and my assistant's going to help me with the second example. Hello, assistant.
Hello, Mr. Nunn.
How are you today?
I'm okay.
All right, folks, so I got TT on board to help me here, and right now she's taking a look at the second story.
Okay. Says, choose a day at random. Because you're a happy person, there's a 0.96 chance you had a happy day. There is a 0.0020 chance randomly chosen day is a happy day and is your birthday. A, sketch this narrative with a Venn diagram.
Okay, so let's start at the beginning. What are the two events that are going on in this story?
The chance that it's just a happy day.
Okay, so we have happy day. And what do you want? What letter do you want to use to represent happy day?
H.
Yeah. Let's not make it too tricky for
Yeah.
ourselves. All right. And according to the story, what is the probability that you are having a happy day?
0.96.
0.96. You are a happy person.
I think
Okay, now what's the other event in this story?
There is a 0.0020 chance randomly chosen day is a happy day and your birthday.
Ah, it says a happy day and
Your birthday.
your birthday. So our other event is birthday. And what's the chance that is both?
0.0020.
All right.
Small chance.
Now, I can't help but notice that the story did not tell me the chance it would be your birthday. Could we figure that out?
We could.
What's the chance that a randomly chosen day is your birthday?
365 days a year? 1 out of 365?
1 out of 365,
What about a
absolutely.
leap year?
Oh, what about a leap year? Well, let's assume it's not a leap year for this
Okay.
example, but if we wanted to, we could put 365.25 there,
Okay.
because there's an extra day every 4 years.
Yeah.
But we'll keep it simple for now.
Yeah.
1 divided 365 gives me 0.0027. All right. So now we can start completing our picture.
Yes.
So here's the circle for it being a happy day. Here's a circle for your birthday, obviously not drawn to scale. So I want to fill in some numbers. So what you want to tend to do here is you want to fill in from the inside out. So start with the overlap. What do you know the overlap is?
0.0020.
Cool. Now, we know that happy is grand total 0.96.
Right.
But 0.0020 of it is here. So how much does that leave to put here?
0.9580.
0.9580. Now similarly, we know this circle for your birthday is 0.0027, but we know where 0.0020 of it is.
Right.
So
That means that 0.0007 is in the circle.
absolutely. Okay, so there's our diagram. Now we're going to go on to question B.
B. Okay. What is the probability it is not a happy day? That's sad.
So probability not happy.
If I remember correctly, it's probability HC.
C for complement is 1 minus the probability that you are happy.
Which is 1 minus 0.96, which equals 0.04.
Absolutely. And then what about C?
C says, what is the probability it is not your birthday? So, just like B, instead with birthday, so the probability B complement. So it would be 1 minus the probability that it is my birthday, which would be 1 minus
0.0027.
0.0027, which is
0.9973.
yes. Okay.
Okay, now we're going to try our hand at D and E.
What is the probability it is a happy day but not your birthday? Okay. So, probability that it's a happy day, okay? So no sleep. And it's not your birthday, so B complement.
Right? So where in this picture is happy and not your birthday?
Here.
Absolutely.
Which means the only thing that fits that would be 0.9580. It's right there. Okay.
Excellent.
So E says, what is the probability it is not a happy day, but it is your birthday? Wow, that is so sad. Okay. H complements, and it is your birthday this time. So the only place on the diagram where it's your birthday, but it's not a happy day, is right here. So that would be 0.0007.
Very good, very good. Okay, now we're going to go to the last part, conditional probabilities. So heading for G.
Okay, so G says that suppose, oh, we're on F. I can't do the alphabet, that's great. Okay, F. So it says, suppose it's a happy day. What is the chance it's also your birthday? If I remember correctly, you want probability of, well, we have this. We already know that it's a happy day.
Yep, so the thing you already know goes second.
And so what we want to know is what is the chance it's also our birthday. So you put the B right here. And then, since it says also, is it P, H, and B?
Yes.
On top, and then the probability of it being a happy day at the bottom?
Yes. So an easy memory trick for this is it's always both on top, and it's whichever one you already knew on the bottom.
Right. So the probability that it's a happy day and it's your birthday is found right here in the center where they overlap, which is 0.0020. And then the probability that it's strictly a happy day,
Which is 0.9600 because it's the entire circle.
right?
It's all of that.
So all of it. It's 0.960. Then we go to the calculator.
And here you are, ma'am.
Okay. No, I just turned on. Okay. 0.0020 divided by 0.9600. You get 0.0021. Technically it's 0.00208, but I rounded, so 0.0021.
Now, don't go thinking this means that it's rare for you to be happy. See, what this says is, suppose you're already happy, what's the chance it's your birthday? Well, because you're happy so often, and it's your birthday so rarely, that's why there's such a small chance here. Well, what about the other way around?
Now, that's what G asked. Suppose it's your birthday. What's the chance it is also a happy day? So, we have the probability that we already know it's our birthday, and we want to know what are the chances it's a happy day as well. So, we have the probability of it being a happy day and your birthday over the probability of it being your birthday. So you take the same overlapping value in the numerator, and then you take the probability that it's your birthday, which is this whole thing, and 0.0027. Then we plug that into a calculator.
So while she's doing that, you already know it's your birthday, so you have to be in this circle. But now what's the chance that you're happy? That means this piece out of the whole circle.
So, value would be 0.7407. Yeah.
So there's a 74% chance that you're happy on your birthday. And so that, folks, is how you can use a Venn diagram to do conditional probabilities. Now it's your turn.